Yes, sorry for that interruption, but let us proceed and finalize. Let us proceed and finalize. With example successfully. If we substitute in our xn plus 1 will give us xn minus our f of xn is xn cubed minus 6xn squared plus 9xn plus 2, remember there is a bracket here, over the derivative, which is 3xn squared minus 2 of xn plus 9. If we take the LCM, our xn plus 1 becomes, there is a 1 there, so into the denominator minus 12xn plus 9, take away xn cubed minus 6xn squared plus 9xn plus 2, everything here over the denominator. What follows next is simplifying in mathematics. Xn plus 1 becomes 3xn cubed minus 12xn squared plus 9xn minus, if we open brackets, xn cubed plus 6xn squared minus 9xn minus 2. The whole thing here is over 3xn squared minus 12xn plus 9. This is where the knowledge of algebra comes from, or the knowledge of polynomials and simplify. Xn plus 1 will give us 2xn cubed, this and this. It will give us minus 6xn squared. The 9xn will go, and then the 2 will be there. Everything over 3xn squared minus 12xn plus 9. If you look at what we have, it is exactly what they asked us to show. The only requirement is to simplify. If we pull out 2 up, we will stay with xn cubed minus 3xn squared minus 1. And if we pull out 3 down, we'll stay with xn squared minus 4xn plus 3. And this is as required. So this gives us what they wanted us to show. It gives us, or it takes us to the point where they wanted us to show that the formula that is required for approximating the root is given by that. And last but not least, we can now move to part 2, where they want us to estimate the root. They have given us that x naught is 0.5 negative. By taking x naught as that, they want us to find the root. I've told you that if you are given such a value, the error will be 0 point. Put a 0 and put another 0 and put that. If you have 1 decimal place there, the error will be to 2 decimal places. So we will be substituting in there. To get our first approximation, we shall fit where there is xn, we put there this. So it will be 2 out of 3 into negative 0.5 cubed minus 3 into negative 0.5 squared minus 1 over negative 0.5 squared minus 4 into negative 0.5 plus 3. When this is computed with your calculator, it gives you negative 0.238. If we check for the TOL, x1 minus x0 will give us minus 0.238 minus, which would be minus 0.5. If we take the modulus, it gives us a value of 0.262, which is greater than 0.005. It is greater than the error in the question. So it means this is not the root. We feed in back this to get our second approximation. 2/3 into negative 0.238. We cube it. Take away 3 into negative 0.238. We square minus 1. The whole of this is divided by negative 0.238 squared minus 4 into negative 0.238 plus 3. If you compute this carefully, it gives 0.197. 0.197, if we check for the tolerance by, again, checking whether the error is less than 0.005, x2 minus x1 give us the modulus of negative 0.197 minus 0.238, and this gives us a value of 0.0141, which is still greater than 0.005. So we try out again the third time to get the third approximation. This is 2 out of 3 into. We are feeding in our 0.19, negative 0.197. This is cubed minus 3 into negative 0.197 squared minus 1, everything over minus 0.197 squared minus 4 into negative 0.197 plus 3. If you compute this and I ask you to compute, you get negative 0.196. 0.196, if we check for the convergence, we get negative 0.196 minus 0.197. This gives us a value of 0.001, which is now less than 0.005. And we can conclude here that the root is now obtained. The root of x is now negative 0.196, which approximately, because they conditioned us to find it to 2 decimal places, they said we should find it to 2 decimal places, is going to give us to 2 decimal places 0.20. So you must be able to continue moving until when your tolerance is less than the error in the first approximation root given. And I must say that this Newton-Raphson method formula gives us the easiest, one of the easiest numbers that you'll interface with. Let us try out our last example for today's lesson. That the equation, you're given that the equation 2x is equal to the cosine of 2x has a root between 0 and 1. If pi out of 4 is the initial approximation, in other words, is the x0, to the root, which is the initial approximation to the root. They want us to show that the beta approximation using Newton-Raphson method is pi out of 8. There are very many silent questions here which we will answer in the process, including finding the Newton-Raphson formula to get this approximation, because that is the only path we can take. That is the only path we can take. First of all, we will let the equation be in the form of f of x is equal to 0. That is a must. The equation must be in that form. F of x is equal to 0. And this implies that our 2x being equal to the cos of 2x will be written as 2x minus cos of 2x is equal to 0, implying that our function of x is therefore 2x minus the cos of 2x. The reason I came in for this topic was a confident position that we had already done trigonometry, differentiation, etc. And even where it requires integration, we have already done it. So we can go ahead and find the derivative of this, which will give us 2. When you differentiate a cos, you get a negative sign, minus 2, the sine of 2x, and this will become a plus. Because when we differentiate, I can just put that to recall the ddx of cos of 2x is negative the sine of 2x. So if we put minus, it becomes a positive. And we already saw earlier today that therefore if we bring in the n point, our initial function is 2xn minus the cos of 2xn, and our derivative is therefore 2 plus 2 the sine of 2xn. So using our expression that xn plus 1 is equal to xn minus f of xn over the derivative of f of xn, we can now substitute in to first find that expression, which will be the same as minus 2xn minus cos of 2xn in brackets over 2 plus 2 the sine of 2xn. If we take the LCM and continue to work through, we shall arrive at an expression that our xn plus 1 is actually going to be equal to xn into, we are taking this as the whole LCM, minus, if I open a bracket straight away, 2xn plus the cos of 2xn. Everything on the right hand side is now over 2 plus 2 the sine of 2xn. So our xn plus 1, upon opening the brackets, is 2xn plus 2xn the sine of 2xn minus 2xn plus the cosine of 2xn, everything over 2 plus 2 the sine of 2xn. Mathematics requires consistency, and that is why people who have done mathematics work in areas where a lot of consistency and efficiency is highly recommended. This will cancel, giving us our 2xn the sine of 2xn plus the cos of 2xn plus the cos of 2xn. Everything over 2 plus 2 the sine of 2xn. So this will be our expression if I don't even move beyond here. And using our first approximation is not as pi out of 4, candidates should be reminded here that our calculators, the moment we start using pi, must be in radian mode. So our first approximation, they told us to show that the better approximation will give pi by 8 will be 2 times pi by 4, I'm substituting in there, times the sine of 2 times pi by 4 plus the cos of 2 times pi by 4, everything divided by 2 plus 2 times the sine of 2 times pi by 4. By computation, this is pi out of 2 times the sine of pi out of 2 plus the cos of pi out of 2, everything over 2 plus 2 times the sine of pi out of 2. But sine of pi out of 2 is 1. Sine of pi out of 2 is 1. And cos of pi out of 2 is 0. And the cos of pi out of 2 is 0. So if I take that straight away, my x1 will be equal to pi out of 2 times 1 plus 0 over 2 plus 2 times 1. This is the same as pi out of 2 divided by 4, which is the same as pi out of 8, or pi out of 2 times 1 out of 4, which gives us pi out of 8. Therefore, our x1 becomes pi out of 8, and since this is the value they had asked us to get, we can conclusively say the better approximation, therefore, is pi out of 8 as required. Is pi out of 8 as required. I want to suggest that we close this lesson here, but I will request those with the USCE book, it is high time that you checked out that book and try to find some numbers to do. Otherwise, in our next interaction, we shall see the next category of questions still under this. The next category of questions still under this. And it is not until our next lesson that we shall now declare that we have looked at all categories, and therefore you are in a better position to try out and pass all the numbers that you will meet under here. But I have the confidence that you can try out numbers in the question bank book under Newton-Raphson, under iterative method, under interpolation, under extrapolation, and find them easy to do. I want to wish you a good day. We catch up tomorrow, same time. God bless you. Have a wonderful day.